China has the fastest growing economy on Earth. But to get to the top, it must evolve. As the country opens up to the rest of the world, Beijing Capital International Airport is struggling to cope with flight overload. 2001, Beijing wins the bid for the 2008 Olympic Games with a landslide victory. But it will bring a huge surge of visitors. There is only one solution, and it's typically audacious. They must build the biggest and most advanced airport terminal ever attempted in just 4 years. A dragon-like structure for a dragon economy.
The scale here is colossal. You know, this is the biggest building on the planet.
Creating this man-made marvel will be an epic struggle that pushes everyone involved to the limit. In July 2001, Beijing celebrates winning the competition to host the 2008 Olympic Games. It marks the beginning of one of the greatest city makeovers in history. They must transform Beijing into a 21st century metropolis virtually overnight. With a booming economy, China has an unprecedented number of construction projects on the go. With this Olympic makeover, Chinese authorities plan even more. A new national theater, the Egg. A new stadium, the Bird's Nest. And a giant Olympic swimming pool, the Water Cube.
They're using these buildings of such enormous size and such groundbreaking technology to show that they are one of the leaders in the world.
With passenger numbers set to soar to a whopping 60 million a year by 2015, Beijing's aging airport will struggle to cope. There is only one solution. They must build the world's biggest airport terminal.
Nothing on this scale has ever been undertaken in the history of our species. It's the biggest thing on the planet.
Today, Beijing's new Terminal 3 is fast approaching completion. In under 4 years, they're close to achieving the unthinkable. The Chinese call it the Dragon. Its astonishing roof that mimics the scales of the beast is so large you can't see from one end to the other. With giant walls of glass, the longest cantilever entrance in the world. And in the belly of the Dragon, one of the largest baggage systems ever built. But Terminal 3 captures the glory of China's past as well as its future. The roof of gold and red evokes the colors of ancient Chinese palaces. It's a connection to China's past that's important to the architects.
The reds, the very intense red, the very Chinese red, the gradations through to gold, the patterns, the shape of the building from above, they're all very evocative of the place.
Throughout history, China has been at the forefront of human endeavor. In ancient times, emperors built gigantic palaces, like the Forbidden City, and engineering wonders, like the Great Wall. These structures pushed the technology of the day to the limit. But a new age is dawning on China as they create a high-tech 21st century metropolis. They've got the vision, they've got the know-how, but they've got an impossible deadline.
The airport had to be operational for the Beijing Olympics.
Back in 2001, the new terminal is still just a pipe dream. It must be built by 2008, or the Olympic teams could be stopped in their tracks before the Games even begin. Beijing's existing airport terminals are aging and struggling to cope with demand. A surge in passengers for the Games could push them to breaking point. In the air traffic control tower, they must cope with the increasing workload.
How many planes are there? It looks like the middle runway has more air traffic. Both east and west runways are at full capacity and no longer meet the requirements of our industry.
Terminal 3 must be completed on time. If not, they'll face aviation gridlock. As the gateway to the nation, this $2.8 billion super terminal will also provide visitors with their first impressions of China. It needs to be awe-inspiring.
I'd like to think that this building will excel every airport that has gone before, and that will learn from our experience. And we have pioneered airport design. We've led it, we've changed it.
Numerous teams enter designs, but one stands head and shoulders above the rest. Foster and partners have designed some of the greatest architectural marvels of the modern age, such as the Millau Bridge in France. Summer 2003, they win the contract. To get their construction plans ready on time, they must work literally non-stop. Project architect Mujan Majidi has never seen a schedule like it.
When we started on the project, it was mission impossible. To meet the deadlines, we had to work 24 hours a day.
Even with commitment like this, there's no guarantee they'll be able to meet the Olympic deadline.
You can commit 100%, but in any building venture, there are so many things that can happen during the life of that construction period. You can have storms, tempests, earthquakes.
Foster is right to be concerned by earthquakes. Terminal 3 lies within a major seismic region. Throughout history, quakes have struck this area, causing destruction. Earthquake expert Professor Ke knows the risks they face.
It lies in a seismic intensity 8 zone. It's very strong, so earthquake-resistant construction is essential in our buildings.
In the past, they were not fully equipped to deal with mega earthquakes, with disastrous consequences. Tangshan, July 28, 1976. A quake strikes the city, registering a staggering 7.8 on the Richter scale. Lasting just 15 seconds, this quake levels most of the densely populated city, killing hundreds of thousands of people.
The Tangshan earthquake in 1976 was an important wake-up call to structural engineers and earthquake researchers across the country.
In the months ahead, engineers must convince the authorities that this enormous structure can be made quake-proof. Terminal 3 will be an incredible 60% bigger than Hong Kong's Chep Lap Kok. Yet they'll have 2 years less construction time. And giant construction projects can lead to giant problems. Building the foundations to this immense structure will be an almighty challenge. Nobody knows whether it can be done, but national pride and Olympic glory is at stake. Foster and partners have won the opportunity to build the biggest airport terminal in the world. Architect Mujan Majidi knows it's an awesome undertaking.
This is perhaps one of the biggest projects any architect has ever taken on board.
Terminal 3 must hold a staggering 150 aircraft at any one time, 120 more than Beijing's existing 2 airport terminals combined.
The scale here is colossal. You know, this is it is the biggest building on the planet.
It's a startling design, but an immense challenge to turn it into a reality. They'll need the best engineers they can find. Mujan Majidi turns to long-standing construction partners, Arup.
The whole system with its quite inherent...
Martin Manning is assigned as their project engineer. He's got overall responsibility for drawing up a construction plan.
In the early stages, there was a great deal of panic because of the program. But as the team got going, there was just generalized hysteria about the amount of work that had to be done.
Manning meets with the Chinese clients to present his schedule. He hopes to start the build in October 2004. The Olympic Games open in only 5 years, and time will be tight. But then their Chinese bosses announce they want to start construction 6 months earlier. Manning is staggered.
When it became absolutely obvious that the deadline was not going to move, your mind gets concentrated pretty clearly about the decisions that you have to take.
Manning's right-hand man, Joe Sumners, has no idea how they'll get the work done on time. But then...
the phone started to ring, and these renowned engineers from around the organisation were sort of picking up the phone and saying, I hear you've got a project, it's impossible delivery time, the engineering's ridiculous, you're bound sure to fail, can I join you?
Construction must start in March 2004, so Sumners and Manning hope to find the site ready and prepared for construction crews to move in. They're in for a big surprise.
When we first drove onto the site, there were still people living in huts.
The T3 site turns out to be a bustling community of 10,000 people. This entire area must be cleared and the population rehoused. This enormous job falls on the shoulders of T3 Vice Commander Madame Xu.
There were 9 villages with up to 10,000 residents sitting right in the middle of this land. And it was a really challenging task to relocate them all.
But Terminal 3 will be important to Olympic success. It takes her several months, but the job is finished just ahead of the official groundbreaking ceremony. Madame Xu is elated.
The first day of construction was on the 28th of March 2004, a really unforgettable day.
They've reached the first major milestone, but a long road still lies ahead. A workforce of 50,000 springs into action.
It was like a scene out of movies. It was like building the pyramids, you know, incredible sight.
Now the construction plans are drawn up, they'll hand over to Chinese firms for the actual build. T3 is so large that it'll take 2 of China's largest construction firms to do the job. They'll each build one of T3's massive concourses, T3A and T3B. Mr. Bai leads the army of workers at the north side of the site and will take on the enormous responsibility of the construction of T3B.
Anything that goes wrong will make us Beijing people, our construction workers, even we Chinese lose faith. So I do feel a great sense of responsibility.
At the other end of Terminal 3, Mr. Zhang is in charge of T3A.
It is almost unimaginable to complete a project of this scale within 4 years. However, the task is right here in front of you. There's no way through except to do it well.
By April 2004, over 100 excavators arrive on site. 217 pile drivers start knocking 20,000 steel piles into the ground. But they've not drilled far before they encounter a serious problem. The water table here is close to the surface. It can rise even further with heavy rains. The teams need specialist expert advice. One man should be able to help. Professor Ke is an expert on the ground conditions in Beijing.
There are two kinds of piles. One is a pressure-resistant pile, and the other is an uplift pile to prevent the structure from floating due to the high level of underground water. We cannot let the building go afloat when the waters rise.
The piles also help protect the building from the risk of earthquake damage.
When an earthquake wave strikes, it takes some time to travel from the south side to the north side of the building. So we adopted a different design from conventional buildings.
Professor Ke's first concern is to ensure that the joints of these long buildings can stand up to one of nature's deadliest forces.
The joints are seen as more important than building components. Joints must be unbreakable.
Ke knows the joints will come under the greatest strain in the corners of the building if an earthquake strikes.
The corner of the building is affected the most by earthquake waves. This will cause torsion of the building.
Torsion or twisting forces can pose a big challenge to engineers. November 7th, 1940, and the Tacoma Narrows Bridge in the United States starts twisting in the wind. Within minutes, the bridge shakes itself to bits. No human life was lost in this disaster, but similar torsion forces could impact T3 in a quake scenario. If the two ends of the building vibrate in opposite directions, the building could collapse. The death toll could be enormous. T3 will need over 1,000 special joints, absorbing the impact should the roof and walls contort. But this will not be enough. Martin Manning knows the steel beams, or members, must also be designed with safety in mind.
What we had to do was to choose the sizes of the members so that they were strong enough to resist the forces that were induced within them.
After 4 months, the design is finished. Manning is now confident that this building will stand firm. Yet earthquakes aren't the only force of nature that T3 must endure.
The variation in temperature throughout the year are very great indeed. It gets very hot and it gets very cold. So on an annual cycle, the movements are quite large.
When this super terminal heats up and cools down, it will grow and shrink by up to 80 centimeters. In fact, the movements are large enough to have a serious impact on the roof's supporting columns.
The thermal movements of the roof are such that as the roof expands, it would have moved those columns too far, it would have bent the columns.
If the roof and columns do bend out of shape, it'll be a major disaster for the engineering team. Beijing's new airport terminal will have an enormous roof, spanning almost a kilometer at its widest point. Its dragon-like scales will silhouette against the sky, making it instantly recognizable. It's a symbol that's important to Terminal 3 Vice Commander Madame Zhu.
When Foster presented the design that symbolized a dragon, we thought it was logical, since China has the culture of the dragon.
It's an awe-inspiring design, but its sheer size could put the structure in serious danger. Steel expands and contracts as it heats up and cools down. In peak summer heat, this roof will grow by up to 80 centimeters at its widest point. Usually, this problem could be solved by building a roof in separate sections. At T3, this is simply not feasible. The roof is a single span and is far too big. Instead, engineers must come up with a clever solution.
We adopted many complicated and intricate methods. For instance, loosening and tightening the joints at different spots to relieve or minimize the pressure caused by temperature.
But tweaking the regular joints isn't enough. They'll need 32 thermal expansion joints positioned between the columns and the roof at key points. As the steel roof expands, the joint glides along a sliding mechanism. The roof can grow and shrink without causing destruction. Terminal 3's gigantic roof may be safe from buckling in the heat. But it's not long before T3's enormous size causes another headache. This time for the baggage engineers.
The system here at Beijing Airport is certainly one of the biggest in the world from a baggage handling system perspective.
Baggage system experts fly in from German engineering firm Siemens. Led by engineer Jeff Martin, they begin to plan a $250 million state-of-the-art baggage system. It's expected to handle an awesome 19,200 pieces of luggage per hour. 68 kilometers of conveyor belt will hurtle baggage around the airport. If Terminal 3 is to be known as the Dragon, this system will be its lifeblood.
The baggage handling system is the veins and arteries of the Dragon.
Getting this giant system to fit inside the terminal's basement is like completing a giant jigsaw puzzle. There doesn't seem to be enough room within Foster's design for such a big system. It causes tension between architects and the engineers.
At some stage, the whole team has to decide whether they're designing a system to distribute bags or whether they're designing an airport terminal.
Then Jeff Martin and his team hit upon a double-decker system, doubling overall capacity at a stroke. But this will create a new problem. They need more ceiling space.
The original Foster's design was designed for a standard airport baggage system. And with the new designs and the new technology required, we had to drop the basement approximately an additional 5 meters.
It will cost not just money, but time. And they must still meet the tight deadline.
Normally a project this size is anywhere from 3 to 4 years in duration. Unfortunately, because of the Olympics, we didn't have that amount of time. We basically had 2.5 years.
The only way to deliver on schedule will be to begin construction of the baggage system whilst the terminal is still underway. As Jeff Martin leads construction, system design changes are still filtering down.
We didn't have time to do it twice. We had time to do it once and time to do it right one time. The person doing the design change is sitting at the computer doing the change. Oh, that's easy, no problem. But realistically, when you actually have to install that into the system, there's a lot of things that can go wrong with that design change.
Jeff and his engineers must rise to the challenge. Despite the painful last-minute design changes, they somehow remain on schedule. The terminal buildings are rising fast out of the ground when disaster strikes at Charles de Gaulle Airport in Paris, France. May 23rd, 2004. a section of the steel and glass roof suddenly crashes to the ground. 4 people are killed, including 2 Chinese. The disaster shockwaves are soon felt in Beijing.
At that time, there was a lot of construction going on in Beijing, and we paid a lot of attention to the accident.
For architects and engineers around the globe, the Paris disaster is a reminder of the importance of safety. The cause of the collapse is thoroughly investigated, but in Beijing, nothing is underestimated.
We were very cautious about the structural engineering and dare not take anything at all for granted.
With so many construction projects underway in Beijing, the Chinese know they must keep a close eye on design and construction methods. The government ensures strict guidelines are applied to all projects to ensure safety. The Chinese architects at T3 have worked hard to safeguard the highest standards.
As the Chinese partners in the project, we have always paid close attention to the safety issue. We have every reason to believe the design is safe.
With 50,000 workers on site, accurately monitoring the work will be no mean feat. Meanwhile, Beijing's roads are on the brink of gridlock. They must build new highways, subways and rail links, or face transportation meltdown. No one wants a repeat of what happened in Athens before the 2004 Olympic Games. With only months to go, Greek authorities had not completed their transport network. They narrowly escaped an Olympic fiasco. But T3 will not suffer this fate. Workers build a giant glass train station and lay train tracks to shuttle millions of passengers to Beijing. Engineers must now ensure the tracks will cope with the load.
What we have to do now is test the construction. We simulate a train in a heavy load situation. Done! One more! Lift this side higher! Done! Are you ready yet? Ready! Cut! Done!
The test is successful, but engineers will have to inspect miles of track before the first Olympic visitors arrive. All passengers arriving at T3 by train will be greeted by Foster's iconic entrance, a giant 800-meter-long overhanging roof. Mr. Zhang's team at Terminal 3A is ready to start welding this structure, but just as work gets underway, engineers realize they're in big trouble. It's an unforeseen problem. The overhang is just too big. It'll stop light from getting into the terminal. Engineers must find a solution, but this will take time. With the Olympics fast approaching, it's time they don't have to spare. October 2005, and Beijing's new Terminal 3 is well underway. Mr. Zhang's construction team is about to start work on the main entrance to Terminal 3A on the south side of the site. Lord Foster has designed a signature piece, an 800-meter-long, 65-meter-wide cantilevered overhang. This sweeping curve is a key architectural statement. But there's bad news.
We ran into a problem in the middle of construction. The original width of the overhanging roof was too large and would cause insufficient indoor light.
It's an unforeseen problem, Engineers could increase the number of skylights to compensate, but this solution could wreck Foster's iconic design. They will have to shrink the overhang. It's cut back from an awe-inspiring 65 meters down to just 35. The entrance will be less dramatic, but it's the only way to ensure Foster's super terminal is flooded with light. Lord Foster also created an extraordinary roof design. The concept looked stunning, but Chinese engineers have never built a roof like it. Engineer Mr. Zhai is daunted by its complexity.
We have never come across something this big. We have never done anything like this before. The many curves also made our construction difficult.
The rolling curves of the dragon's back may be difficult to form from steel, but the dragon scales will also pose a challenge to engineers. The positioning of all 361 skylights will be critical to optimizing the sun's rays in T3. Arup engineer Roger Olsen must make sure each one is in the best location.
The vertical parts of the roof light face southeast, and that lets the early morning sunlight in. And then as the sun climbs higher in the sky, it goes through the horizontal glazing.
With each skylight now located, the iconic dragon roof begins to take shape.
And that was a phenomenal kind of experience, actually seeing the roof structure being sort of stitched together throughout the footprint of the building.
They install 300,000 square meters of roofing panels in just 4 months. With the roof near completion, Terminal 3 is a step closer to the impending deadline. The 2008 Olympic Games will bring a surge of visitors. To cope, Beijing must undergo one of the biggest transformations in its history. Terminal 3's completion on time is central to the city's ambitions.
The project has a really short construction period. We have to put it into use by the 2008 Olympics and make sure it serves the Olympics smoothly, which puts great pressure on us.
As the Olympic clock counts down, her team must think about airport safety. For the terrorists, Terminal 3 could provide an attractive target. The baggage system must be made terrorist-proof. Yet with the volume of luggage going through this terminal every day, an estimated 250,000 bags, it's a tall order. The world knows what just one rogue suitcase can do. In 1988, Pan Am Flight 103 took off from London Heathrow, heading for New York. Less than an hour into the flight, the plane exploded in mid-air over the village of Lockerbie, Scotland. People and debris rained down from the sky. In all, 270 people were killed. It's a security expert's worst nightmare. No one wants another Lockerbie on their hands.
Certainly, Lockerbie does enter into your thoughts relative to your baggage, to making sure your baggage is secure, that it is safe, that you don't have contraband, explosives, anything that's not supposed to be in there.
The chance of a bag containing a bomb is less than 1 in a billion. But passengers want to know they are totally safe. Jeff Martin believes Terminal 3's security system offers the best protection available.
I'm certainly confident with the state-of-the-art technology, the new systems using the computed tomography, that the bags that do get on the airplane are safe.
It's one of the world's most advanced X-ray systems. Developed in Germany in their airport laboratory, Siemens have created the ultimate security machine. State-of-the-art scanners will examine 600 bags per minute. Powerful computers search for traces of explosives at lightning speed. Jeff and his team have minimized the potential bomb threat, but now have an everyday problem to contend with. How to transport bags between terminals 3A and 3B, a distance of over 2 kilometers.
A conventional conveyor system wouldn't work, so it required new technology, an updated technology, of a higher speed conveyor system.
In place of a conventional conveyor, they install a 4-stage high-speed belt to whisk bags from T3A to T3B. Luggage is accelerated to 40 kilometers per hour in just 5 seconds. With all the luggage system problems now ironed out, the project is still on schedule. Just. Today, Jeff and his team are testing the system in order to see if it will cope with the intense workload. The test will begin at T3A's check-in desks.
Right, we're nearly ready to go. When this airport's finished, it will be the biggest in the world. This can do something like 20,000 bags an hour. Might as well start on them now.
In the control room, they track the progress of the baggage around the airport.
Okay, I just need to know how many bags we have already let through. It's the same problem we had yesterday. It's the CTB04 and the check trigger signal. I would talk to Jackie to check that out. We're almost done, but we're facing also some problems now with the manual encoding in T3B.
Coming through the tunnel.
Yes, having some stuck on bags there. We can have a look later to the screens. All right.
They're testing their machinery to avoid the worst-case scenario, a system-wide failure. The prospect of any such breakdown affecting Olympic guests would be unthinkable.
If the system fails during the Olympics, it'll be not only a disaster for Siemens, it'll be a disaster for the Chinese government. It'll be an embarrassment that'll be seen by the eyes of the world. So out of the 5,000 bags for today's test, how many are through the system already?
4,500.
So we're almost done with the test then?
Yes.
All right, the rest of the system looks like it's operating pretty well today then. I'm pretty happy with this.
Yes.
All right, thank you.
You're welcome.
The system has coped with the strain. Jeff is relieved. The hard work is paying off.
In my mind, this system, the baggage handling system, is more of an engineering marvel than the building. And maybe I'm biased, but this is certainly one of the most sophisticated baggage handling systems in the world.
The project is all running to schedule when new aviation data comes through. Passenger numbers have rocketed beyond even the wildest estimates. Beijing's existing airport terminals were designed to serve 35 million passengers a year, but already serve a staggering 48 million. 24 months into the build, airport authorities suddenly realize they need an entirely new building, Terminal 3C. The world's biggest airport terminal will not be big enough. They had planned to construct T3C in 2010, but that would be too late. They must start the construction now. It's a major strain on the schedule, but Madame Xu is determined to forge ahead.
T3C is in the middle of T3A and T3B. If we needed further expansion in the future, the construction could cause conflict with airport operations.
This is no minor addition to the infrastructure. The requirement is for a building of over 80,000 square meters. It'll take 20,000 tons of steel and 80,000 cubic meters of concrete. It'll be a massive job, but the deadline can't be changed. Terminal 3C must be ready for the Olympics. Beijing's Terminal 3 is on track to meet the Olympic deadline when an unexpected challenge arises for Madame Chu. With passenger numbers going through the roof, this super terminal now needs an entirely new building, Terminal 3C. They have only 23 months to make it happen.
The construction of T3C will at first be mainly to serve the Olympic teams. We anticipate that about 80% of them will come in as groups, so we will let them go straight through T3C.
T3C can now transport Olympic teams to the Games. But as T3 races to the finish, the whole of Beijing is under pressure to be ready on time. A citywide makeover is in its final stages for the Beijing Olympic Games. Every construction project must be completed by August 2008. Terminal 3 will be the gateway to this 21st century metropolis, the biggest airport terminal ever built. As the gateway to not only the Games, but to the whole of China, it's essential T3 is up and running. On the 30th of April 2006, the roof and structure are finished. It's a moment for celebration. Madame Chu is rightfully proud of the work they've done.
I felt almost like it was my own child. From the very beginning, I could only keep trying. Now that it's almost complete, it's like my child is turning into an adult and it's time for him to make his contribution to society.
175 escalators and 437 travelators help speed passengers through this colossal building. 445 elevators must be installed to connect this 7-story terminal. For the engineers, it's the culmination of 4 years of toil.
Every cubic meter of the cement used for the construction of Terminal 3, every steel pile, they have our sweat on them.
But will their efforts be enough to make this the greatest airport in the world? The interior aims to be every bit as impressive. The structure now stands tall. Glass walls gleaming as far as the eye can see. It's a distinctively Chinese triumph.
The use of the colors, the temple-like marching of the red columns, it's very much about Beijing, and you wouldn't expect to see a terminal like this anywhere else.
The vast steel roof curves like a sleeping dragon against the Beijing skyline. Its triangular lighting vents beam daylight throughout the building.
As soon as you step through the front door and you're presented with this huge, vast space, probably the biggest enclosed public space in the world. You know, it just takes your breath away.
Not only in construction, but also in terms of economic development, China is right at its peak.
T3 marks the rise of this modern economic giant, propelling itself into the 21st century. A man-made marvel. An iconic gateway to China that all of her people can be proud of.